Hey everyone, welcome to my session called Master Azure Resources, like Marvel's Lord Chaos. My name is Peter Detender. I'm a Microsoft Technical Trainer at Microsoft. If you got any questions or you just want to stay in touch, feel free to reach out on Twitter at PDTIT, send me an email petender@microsoft.com, or follow me on my blog aka.ms/pdtit. In the next 45 minutes to an hour, I want to provide the following learning objectives. First of all, who is Lord Chaos and why am I talking about him? Next, what is chaos engineering about and why is it important? Mainly sharing that it's not just the next cool thing in technology, although maybe it is, but it's also not a replacement for DevOps or site resiliency engineering. Next, I'll focus a lot about Azure Chaos Studio, a rather new service in preview in Azure Platform, which helps customers doing chaos engineering. And then last, this session will help you having conversations with your internal teams about what it takes to build resilient workloads on Azure, and on top of that, testing, validating if they're actually running resilient. So with that, a little bit about Lord Chaos. So Lord Chaos is, I would say, one of my, I wouldn't even say favorite Marvel characters, but it's a little bit, I would say, unknown character within the broader Marvel family of characters. Now, since it fits perfectly in this science fiction oriented topic, it's overall an abstract cosmic entity, that's the official Marvel definition, that embodies chaos, disorder, randomness, and formlessness. Together with his brother, Master Order, they ensure and represent the balance between chaos and order for the well-being of the universe. Performance in Avengers, like meaning having a performance there, I would say, fighting Thanos, but also in Fantastic Four, Silver Surfer, and Doctor Strange. So I would say maybe partly out of like what Marvel movies have been coming out last couple of years, they might have a little bit more of a presence there. And that's where Lord Chaos is also showing up. And then overall, Lord Chaos created another character called Audit as a gesture of reconciliation with his brother Order. So I would say while it's a rather unknown character of the Marvel comics, I personally like the stories a lot as it highlights the constant battle within families, like maybe fighting between brothers or sisters, but also the struggling among friends or overall the struggles in life, like having work challenges, financial challenges, where you need to make decisions you got to make every single day. And this could also reflect the constant duality in cloud platform environments such as Azure, where having it high available means it's probably a bit more expensive. But it also means that you are continuously catching up on the changes in the platform, providing new features, but also my personal interest to continuously learning about the platform and becoming an expert in it. So that's my little take on Lord Chaos. Next to that, who's this weird character called Peter Detender? So as you already know, I'm a Microsoft Technical Trainer, moved into that role about 3 years ago, and recently, about 3 months ago, moved from Belgium to Redmond. I'm a Marvel Comics fan since the mid-80s, so when I was like 7-8 years old and barely able to read. And on top of that, getting access to comics was actually pretty hard. So each and every magazine I could get my hands on, every couple of months when we went through a larger city in Belgium, I could get me some comics, and obviously was like super excited whenever I could get my hands on it. From a professional perspective, I'm a day-to-day Azure Technical Trainer focusing on Azure architecture and Azure DevOps, where before cloud about 10 years back, I was mainly known as an overall Microsoft data center consultant. A little bit of free time that I have. I'm a technical writer, been publishing technical books where I'm currently writing my next one. It will be book number 8 in 8 years, so I'm pretty excited about that. And still blogging on my personal blog, 007fflearning.com. Good. So with that, let's jump into the technical part of the session and highlighting what chaos engineering is about. Now, based on a definition from Principles of Chaos, which if you ask me could be a name of a metal band or maybe a group of Marvel characters, They describe it as chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. So there's a couple of important keywords here. First of all, it's experimenting. Now, if you know a little bit about DevOps, it's about failing fast. Now, why is that? Because the faster you fail, the faster you're going to pick up something again. So you're going to learn from it, and that's what's going to help you moving forward. I call experimenting like licking a power fuse and see if your hair spikes, or when you're a little kid and you're not really afraid of doing anything crazy, right? So like in my case, going downhill with your bike and then testing how fast you could go. And then obviously you're going to fall, going to break your arm, and that's also experimenting. Like, ooh, this was fun. But your mom is telling you, like, please don't do that again. So that's experimenting. Next to that, it's typically out of the chaos engineering definition. It means testing against production running systems. Why? To identify, find loopholes, pitfalls if you want, in the way the system is running, but also what makes it less reliable. So the more loopholes you can identify upfront, the more confidence, which is another important keyword, you can have in the system's reliability. By introducing a series of event simulations, whether based on real incidents happening earlier or based on, imaginary outages that could happen, you're going to target your workloads and learn from that impact. Where again, it's all about testing your production-ready systems. Now, honestly, it's really, I would say, the core of chaos engineering, but nothing's going to block you from testing it against your test environment, development environment, or staging, although they're not always exactly the same as your production environment. So, in short, the core statement of chaos engineering is really that we want you to test to break down your production environment. And based on the lessons learned, you're going to make it better. That's literally what it means. Where obviously there's a lot of stuff you can plan for, like a planned outage or planned maintenance. That could also be part of the story. But it's even more important to actually focus on everything that you cannot plan for. So it could be heavy load. One of the scenarios we've seen at the start of the pandemic about 2 years ago was that Azure data centers were suffering. Was it an Azure problem? Well, honestly, it was. But we were not really the root cause of it. Out of Microsoft, I mean. It just happened because a lot of customers were not able to go to the office anymore, and they needed team calls and relying on VPN connections to connect to Azure instead of connecting to their on-prem data centers, and so many other reasons why customers were quickly moving to cloud. And yes, there was a spike in Azure usage during a couple of days and actually a couple of weeks. Across different regions was the other phenomenon where some regions across the globe were hammered a little bit more than other ones, where now all of a sudden customers started migrating or deploying workloads across different regions and actually spreading out that impact. So that's just one single scenario. Another one could be overall CPU spike, where one example I'll touch on later on is CPU pressure. It means that you're gonna hammer your machine under heavy load, and you did not really prep for it because you don't really know what's gonna happen. And important is you don't really know. And I know we all have those examples where you could think of like Black Friday or other big events like the Super Bowl in the US or overall holiday season around Christmas or any other holiday season coming to mind, where everybody's going online, buying new gifts and everything else. But sometimes you might also have unplanned spikes, where over the last couple of years, we talk to customers like, you know what, you can use scale sets in Azure, allowing you to use virtual machine pools or using scale sets on web apps. Even finding out that it was not really always that reliable, again, based on all the details from unpredictable usage. And that's where customers were not always deploying it in the correct way. So Azure as a platform could probably handle the load, but the configuration in the way customers were deploying it was maybe not good enough. So there might be load, and load was unexpected, and load was not really estimated for. And that's that last part in the definition here is turbulent conditions, hitting something that you cannot plan for. And that's what we're going to try and fix, where chaos engineering, and the harder we're going to hammer it, will help you again in having a more solid, better runtime of your environments. Long definition, but nevertheless quite important. So one example I touched on is the curious case of CPU pressure. Now, what does it mean? Imagine you have a workload. Could be anything. Could be a web server, could be a database server, most probably a web server and database server together. And it's been running fine for months. And you know the average CPU load. How do you know that? Because we got Azure monitoring tools. And yes, I know maybe you're using monitoring tools outside of Azure. That's totally fine. Not even important. But then suddenly there's a CPU spike with a couple of examples I already shared. And eventually, when you're going to hammer your system, it's going to blow up. It means it's going to crash the application, your database is going down, your web apps are going down, virtual machine, database workload, and again, it doesn't really matter. Now, apart from the troubleshooting the data, looking at CPU spike, you're probably going to hand over that task to your engineering team, or maybe your DevOps team overall, and you're going to learn from that. But it might not be good enough, and the reason why not is because you're just focusing on one single workload. You're going to target that specific virtual machine that crashed, or you're going to target the web app that crashed. Now, maybe in a Kubernetes environment where your parts are going a little bit crazy up and down, pods are starting, stopping again, and you want to fix that behavior, right? So that's where CPU pressure language I'm using is one of the so many examples. But what we typically see in things like fixing issues or troubleshooting is that you're going to start from that one single endpoint. Next, I have also included the human being here. There's still a huge amount of issues in running environments because of human interaction. And don't forget, we're mainly talking about production workloads, where something or a lot can actually go wrong. Now you know I like DevOps. I truly do. And sometimes I call it DevOps. Why? Because there's always something going wrong. And it's always like on a Friday afternoon where you want to go out having a drink and the weekend starts, right? And that's where your manager calls you like, oh my God, we blew up our servers, or our e-commerce environment is down, or it's the end of the month and our HR application crashed. We need to fix pay stubs, scenario like that. So we need to make sure that everybody's getting paid over the weekend because it's the end of the month and obviously everybody wants to get paid, right? Stuff like that. So you probably recognize those examples. And that's where I would say the DevOps engineer, without pinpointing anyone, is coming to mind. Now don't take it personal if you're a DevOps engineer. There's nothing negative about being a DevOps engineer or pinpointing anyone. But it's not that easy to just go out because of that problem occurring and assuming that the DevOps team is just gonna fix it. Now don't get me wrong. Chaos engineering is a lot more than injecting outage triggers to bring production environments to its knees. There's a lot more complexity involved, specifically since an outage is typically not caused by one single failure, but more of a series of incidents. Like reusing my CPU pressure example, one could consider a scenario where CPU is spiking because there might be a latency in database operations, putting a calculation or a database on hold. Or maybe there's a network connectivity issue by which an operation cannot be written to the database, which by itself is causing many retry operations, and in turn that's going to spike CPU. So instead of just simulating the CPU spike, it's also important to capture all possible side effects that could actually cause that CPU pressure. So in my analogy, I would say scenarios coming to mind and mainly about complexity is running virtual machine scale sets. It's a lot more complex than just managing one single virtual machine. Or something complex as a Kubernetes environment, where you have the Kubernetes API server, you got the Kubernetes nodes, you got the networking, the security part, the Azure platform backend with load balancers, Azure VMs, virtual networks, storage, and everything that builds up your Kubernetes under the hood infrastructure. Or maybe if you have like a combined workload scenario, where you're going to use complexity from IaaS, infrastructure as a service, and also touching on platform as a service, where part of the workload is running on VMs, part of the workload is running in Azure Functions, containers, web apps, Azure Functions, Cosmos database, that kind of workload scenario. And then back to the human factor, the complexity of having global DevOps teams spread across the world, and maybe they need to work together during a pandemic, where they cannot really see each other in the office anymore. Good. Now, you might think that chaos engineering is the next big thing. maybe coming after site reliability engineering, or maybe coming after DevOps. But maybe it's a bit too, I would say, revolutionary for cloud environments, or maybe your cloud environment. But nothing is more wrong. In fact, chaos engineering has been around for more than 10 years already, initiated by software engineers from Netflix already in 2008, where they were starting to migrate from on-prem workload data centers into public cloud data centers. Now, while there are a lot of similarities across managing your own data center and using public cloud, there's also a lot of big differences. It was mainly those differences that forced the Netflix engineering team to create their own service, providing higher resiliency. Now, to be clear, chaos engineering is not DevOps 3.0, but definitely should be part of each DevOps team's arsenal of tools, or mindsets, or concepts, or procedures, right? To meet the business requirements of providing more value, that's mainly what we do with DevOps, but also guaranteeing that the systems, the workloads they're deploying out of DevOps pipelines are running in a reliable way under any scenario or circumstance. So with that, let's make it a little bit more Azure technical and talking about Azure Chaos Studio specifically. Azure Chaos is a preview Azure service offering chaos engineering as a service, which means you don't have to deploy anything besides enabling the service and deploying your workloads and running it from there. In core, it allows you to inject faults into your running Azure workloads. Now, whether you're testing how applications will run on Azure, or you're migrating workloads to Azure, or maybe you just want to validate applications already running in production in Azure, Azure Chaos Studio provides that full set of faults that can be integrated into any possible scenario, ranging from virtual machines, testing application services, interacting with Kubernetes clusters, all the way to simulating impact across different regions. Now, the core of Chaos Studio is what we call Chaos Experiments. A Chaos Experiment is an Azure resource that describes the faults that should be run on the resource. Those faults should be run against. Now, faults can be organized to run in parallel, but they can also be spun up sequentially, really depending on your needs and what you want to get validated. Chaos Studio supports two different scenarios of faults. The first one is service direct faults, which runs directly against an Azure resource where it doesn't need any installation or instrumentation. So, for example, you could simulate or actually trigger a reboot of Azure Cache for Redis, or adding network latency into AKS Kubernetes pods. On the other side, you have agent-based faults, where you need to deploy an agent. So the typical endpoint target would be a single virtual machine, multiple virtual machines, or a virtual machine cluster, like a virtual machine scale set, where you're going to perform in-guest failures. Think back about my CPU pressure, but could be virtual memory, could be killing a process, and so many other scenarios you can think of. Each fault that you define has specific parameters that you can control, like when the process should be killed or how much memory should be used, and simulating that memory CPU pressure I already talked about. When you build a chaos experiment, you define one or more steps that execute sequentially, each step containing one or more what we call branches that run in parallel within a step, and each branch containing one or more actions, like injecting a fault or waiting for a certain duration. And then finally, you organize the resources that we call targets that each fault will run against into groups, and that's what we call selectors, allowing you to easily reference a group of resources in each action. So it all starts with experiments. You're going to define steps like literally a step-by-step process. If you want to hammer the CPU, cool, that's going to be step one. Where next to that, you're going to simulate latency. Or I'm going to fire off a crash of a web server or a web application, or maybe injecting a heavy database task, or anything that's running inside a virtual machine. Or again, maybe, obviously, Kubernetes, where you're going to target pods, and I think that's a pretty obvious example, maybe even shutting down nodes and testing the behavior of your Kubernetes cluster. And then in the next step, you're going to define the actual actions. Actions are reflecting, this is what I want you to do. I want you to simulate an action called CPU pressure, just an example. Within that CPU pressure, I want you to run CPU load for 99%, maybe 20%, 50%, whatever number that could be relevant for your testing. And literally finding like what's the maximum barrier that we can reach before my application is crashing, right? And on top of that, you're going to define the duration. How long is this action actually running? Which could be 5 minutes, 10 minutes, maybe 3 hours, although that feels like a pretty long test to me. You probably don't need 3 hours to figure out if your virtual machine can handle the load or not, right? So what do you need to get started? Pretty obvious, you need an Azure subscription. I know, but it's on here. Even better, you need an Azure subscription in which you're going to enable Chaos Resource Provider. Now, since it's a preview feature, I'm pretty sure that it is not enabled in your subscription yet. So you go into your subscription options, search for Resource Provider, and you enable Chaos. Microsoft Chaos is the official name. It takes a couple of minutes. If you cannot find it in the portal, you just go into the subscriptions, and from there you can search for it. Next, you're going to enable Chaos Studio User Managed Identity, and I'll show you later on in a demo how to do that and how it works. Next, it adds another service, or it's depending on another service called Application Insights. Where Application Insights, where some of you might already know this, it's a part of your Azure Monitoring family of products. And it is responsible for what we call observability. From there, you're going to send metrics detecting things like a CPU load, figuring out if that CPU load is actually happening, and it is immediately reporting back to the Azure metrics out of the virtual machine resource, the scale set, the Kubernetes cluster, the app service, whatever scenario that's coming to mind. And then obviously last, you're going to define your target. And if there is nothing to target, then obviously you don't have anything to test, right? And it actually have a demo on that as well. So later on in the next couple of minutes, I'm going to walk you through that full process. Now the target scenario can be a Linux virtual machine. And on a virtual machine, there's a couple of additional steps. Well, I wouldn't say it's a heavy step, but you need to install what we call stress ng. So what it means is, out of the box, you deploy Windows virtual machines. You don't really need to do anything. That agent out of the Chaos Studio gets installed. You're in control. You define how to install it. Could be automated with ARM templates, because in the end, it's just an agent extension. But inside that Linux virtual machine itself, could run any flavor like Red Hat or Ubuntu, why not? But you need to install that stress ng application inside the virtual machine. It's not a Microsoft tooling, it's not a chaos engineering specific tool, it's just a stress test tool for Linux operating systems. Where on the other side for Kubernetes cluster, you're going to rely on an open source tool called Chaos Mesh. Where Chaos Mesh is a standalone tool, again, nothing coming from Microsoft, nothing specific to chaos engineering, but it allows you to test your chaos targets or your chaos actions and experiments, I should say, against your chaos-defined targets. And there might be other tools. Again, think back about one of the scenarios or the backgrounds I talked about a couple of minutes back around chaos engineering, where Netflix was already integrating this concept like 10, 12 years ago, where they migrated from on-prem to cloud. Part of that scenario was involving stress testing to find out how public cloud environments could actually handle the load that Netflix was looking for. And again, before they were running it in their on-prem environment. So one of those tools was called Chaos Monkey, and it's still available today. So if you don't like Azure Chaos Studio because it's still in preview, but you like the concept of chaos engineering, you might just search for Chaos Monkey, reading through the docs and actually installing that one. But why would you make it so hard? If Azure is already your runtime environment, just know that it's already available today. And preview doesn't mean that it's a non-finished product, right? I know it's not really the final general availability product, but there is already support out of the product teams. And in the end, you want to make sure that you can test your resilience engineering, your reliability engineering. So we're somehow moving into chaos engineering overall. And from there, the main reason is making sure that whatever you're going to deploy in production on the platform is going to run fine. So that's also a little bit on the background. So that let's switch to my demo environment, where I'm going to walk you through a couple of deployment steps you have to go through, how to define a target, how to define an experiment, running an experiment, and then showing you the outcome of that. So this is my Azure environment where I already enabled Chaos Studio. And again, if you don't really know how to do that, you go into your subscriptions. And within your subscriptions, you're going to search for resource providers. So go a little bit down here into the resource provider section. And that's where you literally enable the Azure Fabric features of the platform, where you're going to search for Chaos. And in my case, obviously, because otherwise I could not really demo anything, you're going to click that register option here on top, giving it a couple of seconds, worst case, a few minutes. And from there, once it's a green registered option, it means you can start using your Chaos environment, or the Chaos Studio service, I should say. So let's jump back to Chaos Studio. And the first thing we're going to do is defining a target. Now, a target is, again, anything that's already running in your environment. Quite important, it needs to be up and running. The reason why is because you need to define how you're going to manage your target. As you can see here, I got two scenarios already enabled. I have my Ubuntu Linux virtual machine where I can manage actions, and the second scenario I got is my AKS cluster. Now you can see that there are a lot of other scenarios available. I can literally target my virtual machine scale set. Over here, I can test against an NSG. I don't have an example for app services, although technically you can actually stop the app service itself. The virtual machine's pretty obvious, but also validating interactions against like a key vault in this case. So it's not just about virtual machines, it's not just about Kubernetes, but it's expanding the target environments. So how do we install that agent, right? That would be the next step, where again, you got service direct and you have agent-based. So for a virtual machine, you're probably going to go for agent-based. So it's nothing harder than selecting your target virtual machine, going up here, enable target. And since again, it's a VM, we're going to install that package. The next step, what you need is a managed identity. Now, what is a managed identity, right? When you deploy Chaos Studio for the first time, you need to create that managed identity. If you don't really know the details, a managed identity is an Azure AD service principal, like a security object, allowing you interaction from one Azure service, Azure Chaos Studio in this case, to interact with other parts of the platform. Virtual machines, NSGs, Kubernetes clusters, app services, Redis cache, Cosmos DB, and so many other services. So that would be step one. I already created my managed identity. Where important, it's a managed identity for the Chaos Studio service. It's not a managed identity for the virtual machine that you're going to use as a target. Second dependency component is application insights. So again, you already know we need application insights for our observability, like providing the metrics, sharing you the output, where you need to dive in your Azure portal, or again, using some automation engine, Terraform, PowerShell, Azure CLI, doesn't really matter. And you're going to deploy your application insight service. From there, you just need to define which one you want to use. And as you can see, I got quite a lot of them because I'm taking monitoring quite serious. And we're going to enable it as well. And that's all it takes. Where from here, it's going to install that agent. Now, to speed up my demo a little bit, I already have this for my Ubuntu VM. And you can validate your deployment. You don't really have to wait in the portal to just validate what's going on. but it's nothing more than any traditional extension. So maybe you're already familiar with using Chef, Puppet, some anti-malware scenario like Microsoft Defender, and installing it as an extension, like adding a little piece of software like an agent inside your virtual machine. Where my portal seems to not be refreshing. Let's try that again. There we go. So I got my chaos engineering and provisioning succeeded. Again, this takes just a couple of minutes, but I didn't really want to wait to show you how it works on the web VM itself. Keep in mind, if it's a Linux backend, you need to install that chaos ng package inside your cluster as well. And again, you could probably find out how to do that using the traditional virtual machine approach for your Linux, like a apt-get, depending a bit on the Linux flavor you're using, would be a good option. So what we have right now is our target. We have the virtual machines defined, and if you want, we could also go back where the deployment is still running, totally fine. Taking a little step back to my Chaos Studio, where now I could target the similar concept, but using a different service. So I'm going to give it a couple of seconds before it's pulling up the capable or compatible resources, and maybe like using my Cosmos database, where this time I'm going to enable it for a direct service model, which means I don't need to deploy an agent. That's really how easy it is. It's going to flip back, but we're not going to wait for it. You probably get the idea how to do that. Where the next step is defining an experiment. I already have a few experiments up and running that I'm going to reuse just to, again, keep it a little bit entertaining, not wasting time on a lot of stuff happening in the backend, but nothing blocks me from showing you how to create a new experiment. So once you have this, it's opening up an experiment configuration. So interesting enough, an experiment by itself is nothing more than a standalone Azure resource. It also means that you can automate the deployment using ARM templates bicep, to just give you an example. And we're going to call this the Lord Chaos experiment. My targets are running in central US, but in the end, it's not really that important. But I typically like deploying my experiments in the same region where I'm going to run my testing or going to run my engineering experiment itself. From here, as I outlined in the presentation, the highest level is a step. Within the step, you got a branch. And out of the branch, you're going to define a fault, where a fault can be multiple actions. You can totally customize the step 1 branch name and adding multiple branches. I'm going to keep it a little bit easy for now because I don't want to run overtime and just focusing on creating a new fault. Where a fault is, I would say, based on a library of fault injections, where a lot of them are already available. And if needed, you can insert some custom ones out of a fault library that I'll show you in a minute. Now, since we have different target endpoints, it means that we can go for different fault scenarios. A couple of obvious ones, like validating the shutdown of a virtual machine or shutting down the full scale set and finding out like what's the impact for my application workload. Specifically targeting Cosmos DB, where again, I didn't need to deploy an agent. It's that direct service direct model. And I can start hammering my Cosmos DB, running a failover from one region to another, shutting down, moving down the RUs, the request units, and causing some kind of latency. And again, testing how my web frontend is responding to that, right? A nice list of AKS specific scenarios, where again, all of them are based on that open source Chaos Mesh scenario. And then from there, a whole collection of standalone ones. Let me change the color to just highlight that it's slightly different. Interacting with Key Vault, like not giving you access to find your secrets, certificates anymore. CPU pressure, physical memory testing, virtual memory, CPU load, stopping a service, killing a process, and so many other scenarios available. So let's check out what that fault library is about. So in the official Microsoft docs, there's a pretty long list of potential faults and specific actions that you can use. Now, the way it works for like the easier tasks or the easier fault validations that I talked about, you can just select it and you don't really have to do anything. But you might also end up in a more complex scenario. Like for example, CPU pressure, quite easy to understand what it's going to do, and it doesn't really require a lot of settings. Now, what you need is a JSON file. You could have like an open source library, again, like Chaos Mesh, giving you YAML syntax for Kubernetes environments, where now out of that AKS-specific chaos engineering testing that we offer out of Chaos Studio in Azure, you need to translate the YAML files into JSON, and that's also documented in this article. Don't worry too much about where to find that fault library. You have that link in the Chaos Studio portal, and I also have it in my slides all the way at the end. Good, so let's go back to our scenario, and we're going to simulate like a CPU pressure. Well, now I can define some of my settings, right? I'm going to run this for, let's say, 10 minutes, and I'm going to hammer my server with 99% CPU. Don't ask me why it's not possible to select 100%, but you probably get the idea, because once it reaches 100% CPU, it's typically crashing the server. Next, we're going to define the target resource, where I'm going to hammer my Ubuntu and the web VM. So the nice thing here is that you can run the same performance testing against multiple endpoints. Could be the same server workload, could be different ones. Like my web VM is running my web engine, my Ubuntu VM is running a MySQL Postgres database, and I'm going to test the behavior when I'm hammering my server with CPU loads. And that's literally all it takes. If you want, you can add a delay, like testing something for like a few minutes. After that, waiting a couple of minutes, testing it again, waiting a few minutes, testing it again. So that's another, maybe more complex scenario. And then adding an additional step is nothing more than doing the same thing, where again, it's going to run through that step-by-step scenario, running through that sequence, where, let's say for now, we're going to kill a process, and the process name is called cmd.exe. Not the most fancy one, but again, this could be like any super important business critical workload where you're just going to stop and kill that process. That's the idea. Where next, while my CPU load is hammering, I'm going to trigger some other process stop. And again, from here, you can add multiple steps, making it more complex, integrating the time waiting scenario. You probably get that idea. From here, you review, create. That's basically it. Now, again, I already ran this process. And what I have is CPU experiments. And then later on, I got something for my AKS cluster as well. Good. Now from here, we have Chaos Studio. We enable the service in the platform. Next, we define target, direct service, or using that agent-based deployment. Step number 3, we defined experiments. As easy or as complex as you want it, targeting a single step with a single fault to a single VM or any single target object, or making it more complex, more complex. Adding VM scale sets, web apps, testing, Kubernetes clusters, and anything else that I already talked about. Now from here, the next step is obviously triggering an experiment. Now before this is capable of kicking off, you need to define role-based access permissions. You need to provide the correct permissions, and interesting enough, it only needs reader permissions, so there's no real security violation, I would say, or security violation, actually better, where the CPU experiment by itself is becoming an Azure standalone resource, which means it has a service principal in the back, and we need to define RBAC permissions. Defining read RBAC, role-based access, for my PDT CPU experiment towards that specific resource. So we go into our target scenario, in this case, my Ubuntu VM. We go into access control, and from there, we're going to define that my PDT CPU experiment gets reader permissions. So we're going to add new role assignment. reader permissions is all it needs. And we're going to specify the member, where my member is PDT CPU experiment. It should be able to find something. Well, not for now, for some weird reason, but you probably get the idea. I'm not gonna wait for it. So now the next step is running your testing. And as you can see, I got a few other ones from other demos that I did, and some of them are failed, some of them are successful. So we're obviously aiming for successful ones. So what I'm gonna do here is kicking it off, starting my process to just show you like what it's about. It's gonna move this into a Chaos Studio processing queue, so nothing really to wait for. And while it is running, you can validate the details. Looks like my portal is running behind a little bit. Now here it tells me, because I was not able to actually define that RBAC, it's literally going to tell me like, too bad it's not working. I don't have permissions to run this, which is totally fine. I mean, I explicitly wanted to show you, but I can go back to another task and showing you the outcome of it. The exact same scenario, I simulated CPU pressure, running a CPU testing during 10 minutes. So you can nicely see here, it started 4:46 and it finished 4:56 and it ran for about 10 minutes. And the outcome is complete. Now, the part that I cannot really show you, but you should probably find out that you could go back to your Azure Monitor, could go back to Log Analytics, going to your virtual machine if you want to run this live and validating, where you go into the metrics, checking the CPU load and seeing that the CPU is spiking up to like 99%. And then after 10 minutes, it's totally dropping back. And at the same time, and that's obviously more important, you're going to validate the impact on your workload. Another scenario for my AKS cluster, why not, is first of all defining your Chaos Studio, we already did, defining the target agent list, so the direct service option, and creating an experiment. Where what I did with this one is defining a step where I'm going to run a predefined Chaos mesh, so that open sourced library, the family of the library that I showed you earlier in the docs, and just grabbing one of those parameters. Where you can see here parts of that JSON, and I don't really know if it's related to the preview, but if I go into edit mode, it's not going to show me the details of that JSON. So that's something I noticed while going through the configuration, that from here it's not really, I would say, publishing, showing you the details of that JSON file experiment. So maybe something to keep in mind during your preview testing, to copy your fold library snippets aside if you don't just want to rely on what's already available over here in that fold library. If you want to spin up a new one, so what I could do here is testing my pods and grabbing one of those JSON files. So that's literally what I did, and you can see it down here. So let's run this experiment as well. We're going to start it, going to kick it off. And the best way to validate your running pods and how they're behaving is running kube control, right? You can validate a little bit of it using Azure Monitor as well, but why not showing you kube control, get pods. Where now out of my experiment, it should run some of my pods and some other ones are getting stopped. So that's literally what we're testing here. So I can see that already in just a couple of minutes, it's terminating and it is restarting once, where the other ones, because there's a little bit of time I kept in between the recording of kicking off the task and moving to the behavior of the pods, where you can see that I'm literally stopping a pod, starting it again, stopping it, starting it again. That's the main scenario we're testing. I'm only running one node in the backend, but you probably get the idea from here. Good. That's all I wanted to show you around Chaos Studio. There's obviously a lot more. I could do the same with like NSG validation, integrating an inbound rule, removing an inbound rule or outbound rule, and again, testing like what's the outcome of that. Now, before we're closing this session, first of all, I hope you enjoyed it. Now, before I'm leaving, I want you to share 2 important last resources. First of all, when starting the conversation around Chaos Studio, just look at it from a broader perspective. And that's where I would say out of Microsoft, we would position the well-architected framework, where chaos engineering would fit perfectly in that reliability pillar of the well-architected framework. It's going to help you identifying some guidance, best practices around how to efficiently run workloads in cloud from a cost optimization, operational excellence, performance, security, and reliability is one of them. There's a link here. You're going to see that link in like 2 slides from now as well. Or this one, I would say here, where this slide is my other important message. List of resources, the public docs for Chaos Studio. And again, remember, it's in preview for now, but you should be good to go. Next to that, you can join Chaos Engineering workshops, where it allows you to participate in virtual demos, in having Q&A with the product teams. You can join an insiders community, allowing you to, first of all, test the preview bits, providing feedback like these are the scenarios. As a company, as an organization, we're looking for, is it possible to validate them, to test them, to integrate them? And also that link I just mentioned, the well-architected framework, specifically focused on chaos engineering. Next to that, if you want to go through a similar demo testing scenario as what I showed you in my 10-minute demo, it's a combination of those 2 articles as well. One for AKS and the other one for an Ubuntu virtual machine-based scenario. It's not the only 2 options we have. I already told you there's a lot more that we can go through. And with that, we're close to the end of my session, where the last part I would say is, first of all, thanking you for having watched my session here. I hope you learned from it. I hope you enjoyed it. I hope I inspired you a little bit about chaos engineering, first of all, and maybe having a look at what Azure Chaos Studio can bring to your environment. Next to that, I was also super excited to be able to share a little bit about Lord Chaos, one of the more unknown Marvel characters, I would say, out of my Marvel comic interest. And last, I would also like to thank Brian for coming up with this brilliant idea around the science fiction inspired, oriented theme of the virtual conference, where I already talked about chaos engineering quite a lot, talked about Chaos Studio already quite a lot, but it somehow needed to tease my brain a little bit, coming up with an original session topic, and next to that, sharing a little bit about my personal interest in Marvel Comics and cosplaying as well. So with that, feel free to reach out, stay in touch, share feedback on Twitter, email, follow me on my blog, and anything that could allow us to stay in touch. Thank you so much for having watched my session. Stay safe, stay healthy, and take care of each other. And with that,